Hello everyone. Today I'm back with another question which is codeforces 1600 rated good triples. This is a really good question and let's solve this question and you'll get a good insight of it how numbers and digit sums are happening. So the question says we are given a integer n and what we need to do is we need to check whether it is good triples or not. Triples in the sense we have to find three numbers a, b and c whose sum is equals to n, and also the digit sum of a, digit sum of b, digit sum of c is equals to digit sum of n. Okay, so this is what we need to find, and how many triples are possible for a specific n value that we need to find and return as an answer. So for example, if I say we have number 11, n as 11, so we can find total of 9 triples which whose sum is equals to 11, like a plus b plus c is equals to this n, and also its digit sum of a plus digit sum of b, digit sum of b plus digit sum of c is also equals to digit sum of n. It's going out, but it's fine. So this is what we need to do, and how many are possible we need to figure out. So let's take an example and see how a digit sum is happening, and we'll see then what are the things that we need to figure out and what are the things that we need to understand while solving this question. So let me erase this first and we'll start solving this question. Now, is it a good triple? How we'll get to know? Just for example, if we have n as 18 and now we need to find three numbers that sums up to 18. So we have an example for 10 4 4 that this sums up to 18, right? And if we do the digit sum of 10, that is 1, digit sum of 4, that is 4, digit sum of 4 will also be 4, and digit sum of n which is 18, it will be 9. 1 plus 8, that is nothing, 9. And if we sum these, it will be 9 which is equals to 9. That means this 1044 is a number which we can take, and we can say that this sum is equals to n, and also the digit sum is equals to the digit sum of n. So this is correct. Now let's take another example for the same n. My n is 18. If I take 9 8 1, this is another example which sums up to 18. But if we see the digit sum for this, which is nothing but 9 plus 8 plus 1, the digit sum of 9 will be 9, plus 8, digit sum of 8 will be 8, plus digit sum of 1 will be 1, which is nothing but 18, and which is not equal to the digit sum of n, which is 9. What happened over here? Like we found a number whose digit sum is also equals to the digit sum of n, but here we found a number abc whose sum is equals to n. That is fine, but the digit sum is not equals to the digit sum of the number. What happened? There's something that is happening over here and we need to figure that out. So let's see with an example. Let's take the same example and see what happened actually. So if we see in the first try, we took a as 10, b as 4 and c as 4, right? This was 10 4 and 4. Now if we do the sum for these numbers, this is a simple sum that we are doing, 0 plus 4 plus 4, which is nothing but 8, and 1 is 1. Now if we are doing the digit sum for these numbers, it's like 1 4 and 4, which is nothing but 9. right? And the digit sum of n that we have is also 9. This time it was fine. But in this case, when I was taking 9, 8, 1 as our A, B, and C, there was something happening which didn't give me the correct answer. Now let's see this. When I did 9 plus 8 plus 1, we figured out that we had a carry. We were getting a carry, and this is what creating a problem. Whenever we are getting a carry, we we are not able to fit this carry in our digit sum. Now I see 9, the digit sum for this is 9 plus 8 plus 1, which is nothing but 18, a direct that number, direct n, which we are getting. But the digit sum of n is 18 actually. The digit sum of n is 9, 1 plus 8, which is 9, and this 9 is not equals to 18. So there is something happening whenever we are getting a carry. In this case, we were not getting a carry. See, 4 plus 4 is 8, direct 8. We didn't get any carry, and 1 is direct 1. We didn't get any carry over here. But when I summed up this 9, 8 and 1, we got a carry. So whenever we are getting a carry, there we don't know where to exactly place this carry. That is the reason this is happening. Now let's take another example which will clarify our answer in a much better way. So whenever we have a, let's suppose our n is 9 and we took a, b and c as 4, 3 and 2. Okay, now what will happen? If we see, this is very simple. 4 plus 3 is 7 plus 2 is 9. We are not getting any carry over here. So directly if I see my digit sum will also be 9 for these all three, and the digit sum of n will also be 9, which is equal. So this is a correct answer. Now what happened when I take n as 10 and my a, b, c as 4, 3 and 3? Now if we do the normal sum, so 4 plus 3 plus 3, which is nothing but 10. Now what happened when n was 9? We had the maximum value of a single digit place. Like this place had the maximum value, which is 9. Now when my n was 10, this place had the minimum digit value as 0. Now whenever we do the digit sum, we'll get the maximum value. You see, we are getting 10. But whenever we do the n, digit sum for n, we are getting the minimum value, which is nothing the carry plus 0. But here we are directly adding the whole sum, digits sum, which is 10. But here we are having 0 plus 1, which is nothing but 1. So they are not same. So whenever we are getting a carry, here we are getting a carry as 1, we can say that the last digit, this was 9, and 1 adding to it will give me a carry 1, and the digit that we had 9 earlier, now it will turn to 0 and we'll get a carry as 1. Now this is a number which is much lesser than the digit sum value of the given number. So we can say that whenever we are getting a carry, n will be, let me write it down in a proper sentence. Whenever we are getting a carry, we can say that the n digit sum, the digit sum of n will always be smaller than the digit sum of individual A plus digit sum of B plus digit sum of C. So this is what we can conclude whenever we are getting a carry. So this means we need to find all the numbers whose carry is not there. So if we take an example for let's suppose 3 3 and 3, our n is 333, right? So we can take we can take the last digit and find all the possibilities of A and B and C. Last digit for A, last digit of B, last digit of C. Like we are finding A, B and C. So we'll have 3 places for A, B and C also. So we need to find all the values, possible values of A, B and C, whose this 3 places, if we do the addition, will give me 3, because we do not want any carry. We want this to be directly. So if we say if we take here 1 1 and 1, this will turn out to give me a 3, and we are not generating any carry if we sum these three value. Now if we take another number as 2 1 and 0, this is also a possibility, and we are not generating any carry over here. See, so this is how we'll be doing it. We'll take the last digit, find all the possibilities for this, which will range from 0 to 9 maximum. This can range from 0 to 9. This can also range from 0 to 9, and this can also range from 0 to 9. But if we find two numbers, we can surely find the third number, because if we found two numbers, we can directly subtract it from 3, and we can find the last number. What will be the last number? So this is this we do not need to iterate. We just need to iterate from 0 to 9, from 0 to 9 for first digit, and for second digit. If we take 0 as our first digit, what will be the second digit? If we taking 0 as the second digit, the third digit will be 3, 0 0 3. It's one of the possibilities. Now if we find when we find all the possibilities of this, let's suppose all the possibilities for this is 5. There are total of 5 possibilities whose sum is 3 if we take ABC. Now we'll remove this and we'll go to this specific digit, and then again we'll find all the possibilities for this, which will also be eventually be 5. Now when we go to this digit and we find all the possibilities over here in this place, we'll get 5. Now we need to find total. So we will do what? We'll simply multiply these three numbers, which will be nothing but I suppose 125. So we are getting a total possibilities of 125. Whenever we do the digit sum for all those, we'll get the digit sum for n. So if we take an example, and let me erase this, it's getting a messy over here, but okay, it's fine. So if we take an example of suppose 2 1 and 0, 1 1 1, and 0 1 and 2. So if we take this as an example, so we know that this digit sum is 3, this digit sum is 3, this digit sum is 3. Now actually we need to do the digit sum for all these. So let me erase this half also. So the digit sum for these is 2 plus 1 plus 1 is nothing but 3. The digit sum for 1 plus 1 plus 1 is nothing but 3. The digit sum of this is also 3. And if we add these 3 plus 3 plus 3 is nothing but 9, a total of 9. And when we add the digits of n, we'll also get 9. You see, whatever the possibilities, if we place 1 1 1 over here, 1 1 1 111. This is also one of the possibilities, and if we do the digit sum, we'll get 9. So we are neglecting all those numbers who whose sum whose normal sum is getting a carry. So we are removing that. We are not considering those in our answers. So let's look at the code. The code is very simple. We need to check. We need to get the last digit. We have this n. We'll get the last digit from n. Now we'll find two numbers, a and b, because we know the third number will always be last digit minus a minus b. So now if last digit minus a minus b is giving me greater than equals to 0 value, then we can create a third number also. Third number can be greater than equals to 0. It cannot be a negative number. So if last digit minus a minus b is greater than equals to 0, we can say that okay, we found three numbers. A is 0, b is 0, and c will be like 3 if n is 3. So I'll increase my counter as 1. And here we are neglecting all the carry part. We are not doing any carry over here. We are just directly taking a, b and c, and a, b and c we are ranging till last digit. We do not want to go more than that. Last digit will always be every digit of n will range from 0 to 9 only, not more than that. And then we are checking, and whenever we found our count for a specific last digit, we'll multiply it in our result, because we wanted, whenever we found a count, all the counts for the last digit, for this last digit, that is find 5, we'll multiply it with the all the possibilities that we found with this, and then we again multiply with all the possibilities that we found for this, and we'll return that as our answer. Now this can also be done using finding all the good triples. Like we found only for this number specific, but if we need to find, we can find for all the good triples. What we can do is we'll create a digit sum array. We'll iterate and we'll find the a, b and c, which will range from 0 to 9, 0 to 9 and 0 to 9. And we will do the addition for all these three numbers and will increase in our digit sum. If you'll try and go through this, you will get this answer very easily. Now we'll do what? We'll again do the same thing. We'll take the last digit, and whatever that last digit will have in our digit sum array, we'll just multiply it with our result, and we'll remove that number from last digit from the result, and then we'll finally return our result. So if you don't get this, please, I recommend you to go back and read the solution again, watch this video again, because this is a really good concept of carry. It will not get to you unless and until you try by yourself, and you figure out with few examples, try some more examples, and then you will get it. Try, here are lots of inputs given. You can try these examples and try to figure out things, why we are getting, whenever we are getting a carry, why this is happening. So like whenever we are getting a carry, the last digit was 9, it changes to 0, and a carry is added, and this number is always lesser than the digit sum of a, b and c. So this is what actually the question is and the solution for this. I hope if you find it good, please do like, share and subscribe my channel. Thank you for watching. Do let me know in the comments if you get any doubt. I'll try to clarify as best as I can. Thank you.